This video is about solutions in chemistry. It includes background information as well as practice problems. Let's get started. We will go over vocabulary, the introduction, how like dissolves like, and then practice problems and concentrations of solutions. Here is some vocabulary. Solution, a homogeneous mixture. A homogeneous mixture is an aqueous solution that is made up of two or more different substances. An aqueous solution is a mixture of a solute and a solvent. A solute is a substance like salt or sugar that dissolves in water. A solvent is usually a liquid, for example, water. Suspension. Particles remain mixed with a liquid while being stirred, but will settle out if let undisturbed. Colloids. Stable heterogeneous mixtures. It consists of tiny particles of intermediate size between those in a solution or a suspension, and thus are suspended in a solid, liquid, or gas. Homogeneous. A mixture that is uniform throughout. Heterogeneous. A mixture that is not uniform throughout. Dissociation, the separating of a molecule into simpler molecules, atoms, radicals, or ions. Hydration, strong affinity for water. Precipitate, a solid that forms when two clear liquids are mixed. Electrolyte, a substance that dissociates in water to form new ions and creates a solution that conducts electricity. Here is some background information on solutions. The more salt you have in a solution, the more concentrated it is. When there is very little salt in a solution, it is called dilute. Solubility shows the most salt that the water can hold, or the most salt that can dissolve in the water at a specific temperature. Temperature, pressure, and the nature of solute and solvent affect solubility. As temperature increases, the solubility of a salt increases. Salt has an ionic bond. A metal transfers electrons to nonmetals. As temperature increases, the solubility of a gas decreases. Pressure then has an effect on the solubility of gases only. It makes them more soluble. It has almost no effect on solids or liquids. Like dissolves like. Polar molecules dissolve polar molecules in ionic compounds. Nonpolar molecules dissolve nonpolar molecules. Saturated. The solution contains the most solute salt that can dissolve at a given temperature. Unsaturated. The solution contains less solute than a saturated solution. Supersaturated. The solution contains more solute than a saturated solution. This is a temporary solution caused by cooling a saturated solution. If something placed in the solution dissolves, the solution is unsaturated. If something placed in the solution falls to the bottom, the solution is saturated. If something placed in the solution causes crystallization, the solution is supersaturated. Nature of solute and solvent affects solubility. Ionic and polar substances dissolve polar solvents because unlike charges attract each other. Water is a polar substance with positive and negative ends. Ionic substances are composed of positive and negative ions. A nonpolar molecule or substance does not have a positive and negative end, so it does not dissolve well in water. CnHNO3 will be most soluble under low or high temperature, high pressure, or no effect, and will be most soluble in H2O or CCl4. Ki will be most soluble under low or high pressure, low or high temperature, high pressure, or no effect, and will be most soluble in H2O, CCl4. KNO3 will be most soluble under high temperature, pressure will have no effect, and will be most soluble in H2O. KNO3 is a salt, so increasing the temperature will increase its solubility. Pressure will not have an effect on it since it does not have an effect on solids. It will be more soluble in H2O because it has an ionic compound, which means that it can be dissolved by a polar substance. CO2 will be most soluble under low temperature, high pressure, and will be most soluble in CCl4. CO2 will be more soluble at a low temperature because as temperature increases, gas solubility decreases. Pressure increases the solubility of a gas, and because it is a nonpolar substance, it should be dissolved by a nonpolar solute. Here are some practice problems. Take the time to work on the problems and then resume the video in order to see the answers. Here are the answers. Is solid iodine soluble or insoluble in water? Iodine is not soluble in water because it's a nonpolar molecule and water is polar, and like dissolves like. Then explain in terms of molecular polarity why hydrogen chloride is more soluble than methane in water at 20 degrees Celsius and standard pressure. Hydrogen chloride is more soluble than methane because hydrogen chloride is polar and methane is nonpolar, and water is polar, so like dissolves like. What type of solution is 80 grams of NH4Cl at 80 degrees Celsius? This is a supersaturated solution because it is above the line. Looking at the table in the reference packet, determine whether each solution is saturated, unsaturated, or supersaturated. Keep in mind that a solution is saturated when it falls on the line, unsaturated when it falls below the line, and supersaturated when it falls above the line. So 80 grams of NaNO3 and 100 grams of H2O at 10 degrees Celsius is saturated because it falls on the line. 90 grams of NaNO3 and 100 grams of H2O at 10 degrees Celsius is supersaturated because it falls above the line. 30 grams of NaCl and 100 grams of H2O at 60 degrees Celsius is unsaturated because it falls below the line. 20 grams of SO2 and 100 grams H2O at 50 degrees Celsius is supersaturated because it falls above the line. 70 grams of NH3 and 100 grams of H2O at 10 degrees Celsius is saturated because it falls on the line. 100 grams of Ki and 100 grams of H2O at 40 degrees Celsius is unsaturated because it falls below the line. You can determine whether a compound is soluble based on Table F. Table F lists ions that form soluble compounds unless it is combined with exceptions that make it insoluble. It also lists ions that are insoluble unless it is combined with exceptions that make it soluble. Here are 2 practice questions based on Table F. Is BHOH2 soluble? Yes, this is soluble because OH is listed as insoluble unless combined with Ba2+, among other ions. Is KCl soluble? This is also soluble because Cl is listed as a soluble compound, and K is not among the exceptions that make it insoluble. Concentrations of solutions. The 2 formulas are parts per million equals mass of solute divided by mass of solution times 1 million, or molarity, moles of solute divided by liters of solution. Here are 2 practice problems. Resume the video to find out the answers. Given 600 milliliters and 80 grams of hot chocolate mix, and that 50 grams is equal to 1 mole of hot chocolate mix, find the molarity. 600 milliliters needs to be converted to liters in order to divide by liters of solution in the molarity formula. So 600 times 1 liter over 1,000 milliliters is equal to 0.6 liters. And then there's the 80 grams of hot chocolate mix. The number of moles is equal to the given mass over gram formula mass. So we have to take the given mass, which is 80 grams, divided by the amount that we know is equal to 1 mole, which is 50 grams. 80 divided by 50 equals 1.6. So the molarity is equal to 1.6 moles divided by 0.600 liters equals 2.67 m, because we need to keep it to 3 sig figs. Given 855 milliliters and 93 grams of hot chocolate mix, and 50 grams is equal to 1 mole of hot chocolate mix, find the molarity. 855 milliliters needs to be converted to liters in order to divide by liters of solution in the molarity formula. This is equal to 0.855 liters. And then the number of moles is the gram formula mass divided by gram formula mass. So that is our 93 grams divided by 50 grams per mole is equal to 1.86 mole. Then molarity is equal to 1.86 mole divided by 0.855 liters equals 2.18 m.